So we've been talking about relations and functions, which is just a relation between two variables that follow some sort of rule. Okay. So what we're going to look at here is just how do we read relations in graph form, and when we're given information, how do we turn that into a relation on a graph? So this first example, we've got a relation between time and the depth of a scuba diver, okay? And we want to answer the following questions. So you're going to be able to read a graph to do these. So looking at this graph, how long did the dive last? How would you find that? Like, wouldn't we just say, okay, here's where it starts, here's where it finishes? How much is that? 30 minutes, right? Because we're going up by twos every time. So here's 28, then we go 2. The graph would, or the dive would last 30 minutes. That's it. At what time, or after how many minutes, did the diver stop her descent? She didn't go any lower. Remember, here she's on the surface. Now she's 12 meters below after 4 minutes. And then she stays there. And then she goes even lower. So wouldn't this be when she hit the lowest part? How many minutes is that? 10 minutes. What was the greatest depth the diver reached? 20 meters. Because you read the vertical. So it's 20 meters. And how long did it take the diver to go from the greatest depth back up to the surface? Well, at what minute mark does the diver start to go back up from the lowest depth? 16?
14.
14, right? And then hits the surface here at 30. So from 14 to 30 is how many minutes? 16 minutes. So it'd be 30 minus 14, which is 16 minutes. Okay, so just reading the graph. This one. Here, we don't have a bunch of line segments, we just have a bunch of points. It's still a relation. It's the relation between the mass of a bag of popcorn and how much it costs. So we want to answer the following. What bag, A, B, C, D, or E, was the most expensive? C, right? Because we want to go to the highest. And how much? $7. Which bag had the least mass? B. And what is the mass? Now you got to be careful how you read this one. What are we going up by every grid line? 200. So 400, this is 600, but B is halfway between 400 and 600. It would be 500 grams. Which bags have the largest mass? C? Do we want to see to the furthest right? D and E, and how much are they? 1,800. So D and E, and they are 1,800. Which bags cost the same? Maybe. And how much? $4. And finally, which of the bags, C or D, is better value for the money? D? Somebody said?
Yeah.
Why?
Because you're getting more and it's less.
Right. With D, you get more and it costs less. Okay. The next example, we're asked to describe what's going on here. Okay, well, we can see from the title of the graph that this person is taking a day trip from Winnipeg to Winkler. And then the horizontal axis is the time that they're driving for in hours. And the vertical axis is the distance from Winnipeg. So let's describe what's happening by breaking it up into segments. First of all, we have 0 to A, then A to B, B to C, C to D, and I'll put D to E over here. So what we want to do is we want to describe what happened and how long did it take. So what happened from O to A? Remember, they're starting in Winnipeg. How long have they driven? 1 hour. And how far are they from Winnipeg?
60 more.
Yeah, like here, this is 70. So maybe halfway in between. So they're about 65. So drove 65 kilometers for 1 hour. What happened from A to B? Yeah, they stopped. For how long? 15 minutes, right? Because this would be an hour and a half, or 30 minutes. So this must be 15. So stop for 15 minutes. What happened from B to C? How long did they drive?
45 minutes.
45 minutes, right? Because this is 15 minutes, this is 1 hour, so this must be 45 minutes. And how far did they drive? Remember, here, this is 65, and this is 130. So 65 to 130. Should get 65. And one thing we want to add to this is notice they're at 130 kilometers away from Winnipeg. They must be in Winkler now. Okay, so they're in Winkler. What happened from C to D?
Are they taking a break? But you can't break.
Yeah. For how long?
So,
2 hours. Or we could say they stayed in Winkler for 2 hours. Stayed in Winkler for 2 hours. Did something there. So finally, after hour 4, they're in Winkler. And then we get this thing. What happened?
You want that to me?
Yeah, drove back to Winnipeg in how long?
2 hours.
2 hours. Drove back. Just put WPG for 2 hours.
Okay, so that's describing everything that happened in that graph. Just break it up into segments. Okay, now what if we were asked to go the other way?
We were given information.
And then asked to graph it.
That's what the next example does. And you see, you've got a graph here you can use.
So this guy Samuel went on a bike ride. He accelerated for 2 minutes at a constant speed until he reached 20 kilometers an hour. Then he biked for 30 minutes at that constant speed. As he approached a hill, he took 3 minutes to go decrease his speed, because obviously he's going to go slower if he's going up a hill, at a constant rate to 5 kilometers an hour. He then stayed at that for 10 minutes as he climbed the hill. And then he took 2 minutes to decrease his speed until he reached a full stop. Okay? So somehow we've got to put all of this into a graph.
Well, usually in situations like this, the horizontal axis is going to be time.
And because everything was described in minutes, we're going to put it in minutes. What would the vertical axis be? Kilometers?
Speed. So we know that this is going to be 0, 0.
No time has passed, hasn't started the bike ride yet, hasn't pedaled yet, so hasn't gotten up to any kind of speed.
We need to figure out how much do we go up by every grid line?
Like 5 minutes, 10 minutes, 2 minutes, 1 minute.
Well, to do that, let's look at
How long did this ride last for?
well, he started pedaling for 2 minutes, right? Then he went for 30 minutes, so now we're at 32 minutes. Then he took another 3 minutes to decrease the speed, so now we're at 35-minute ride. 45-minute ride because he cycled at a constant speed for 10 minutes. 47 because he decreased the speed. And then he also stayed at a stop for 10 minutes,
So 57. So about 60.
Obviously, I can't go up by once because I don't have enough grid lines to get to 60.
What about twos? Is that enough?
No, I need a whole bunch still.
What do you think?
5? Sure. So what I'm going to do is instead of just doing every single one, I'm going to do every second one.
So I'm going to get that. That'll be enough to cover the bike ride. Now, what about the speed? What should we do for the speed? Well, obviously we need 0. What's the highest speed he reached? 20, right? So what do you want to go up by? 2? Somebody said? Yes? Yeah. That's a good idea. So 4, 6, 8, 10, 12, 16, 20. That'll work. Okay, so now we want to put in the segments of the graph. So he went for 2 minutes until he hit 20. Well, 2 minutes is less than half of a grid line. And then he went all the way up here. So his first one is going to be a really steep segment. Okay, so we did that one. Now we stayed at 20. So we're going to draw a horizontal segment for how long? So we're at 2 minutes here. We've got to go to 32 minutes, right? So we've got to go to about here. Okay? That one is done. Now we took 3 minutes to go down to 5 kilometers an hour. Well, 5 kilometers an hour is here. Remember, we're at 32 minutes. So if we took 3 minutes, what are we at? What are we at after 3 minutes? This is 32. And then 3 minutes later is how many minutes? 35. So that means we should be here. And that's a pretty steep segment too. The next one's pretty straightforward. We're at the 35-minute mark. He stayed at that speed for 10 minutes. So we just have to go from 35 to 45 and draw a horizontal segment. So we're at the 45-minute mark. He took 2 minutes to slow right down to 0. So we went from 45 to 47 all the way down to 0. So we're at 47 and he stayed at 0 for 10 minutes. So we go from 47 to 57, about this. And that's what the graph should look like. Okay? So out of this, you should be able to read relations off a graph, actual relations. And you should be able to graph a relation given a situation. This last one, I'm not going to write anything, but here's where you have a chance to be creative. Can somebody come up with a situation for this? Just tell me what's happening. Just give any example you want. Usually time is a good one, like I said. So you could have height, you could have weight, you could have distance. Really? No creativity? Your creativity's been stifled? Yes, Sadie?
I'm not sure.
Okay? So notice they don't start here. So where are they starting?
Like, how many days? Or,
Well, no, because like if this is distance, right? You said somebody's going on a trip. Normally they'd start from home, right? But that means that the graph would have to start here, but it starts here. So they're a certain distance away from home, aren't they?
yeah.
Before they start. So I don't know, they're at a friend's house. Okay, then what do?
They drive to the airport.
Okay, they drive to the airport. It takes them however many minutes to get to the airport. They're at the airport here. What happens here?
They go to the,
Okay, so they're still at the airport.
yeah,
Good, yes. What happens here?
they go.
They go where? Like drive, like take their car on the runway and speed up? Oh, okay, that's pretty good. So they're at a friend's place. They drive to the airport, stay at the airport, waiting for their flight, and then take off. So the speed goes up. Excellent, good. Anything else? Nothing? So Jackie, I can see you sitting there laughing. Okay. This represents her stress level. Okay. So she's moderately stressed. Okay. There must be a physics test. Okay. So she walks to the physics classroom, takes her this many minutes, and the stress level goes up. Not much, but a lot, or sure, a little bit. And then that stress level stays the same. Then she gets the test, reads the questions, and here's what happens to her stress level. There you go. There's another one. How about this one? I know that would never happen in a math. What do you think? Any ideas? Nothing? And time? Time is usually a good one. Oh, gosh. Yeah, roll.
Like, pitch, like if you're singing and it's like starts at a low note and then goes back.
And it starts what? Okay, so you're playing an instrument?
Yeah.
Sure, that would be good. Okay. What about you're on a Ferris wheel? Would this look like what would happen on the Ferris wheel? Or would this be what happens on a Ferris wheel? Which one? The purple or the red one? Why not the red? What's wrong with red? Remember, this is time. Like you'd start at a certain height on the Ferris wheel, then you'd start to climb, and then you'd start to go back in time as you're climbing.
and then you hit the top as you go back in time, and then time continues forward again. What's that? That is correct. So this would make more sense because, first of all, you don't start here on a Ferris wheel, because that means the Ferris wheel would be on the ground. And how would it be able to spin if it's on the ground? So it's going to be a little bit above the ground. And then you go up, you peak, and then you come back down. And then you can start again if you want to keep going. Okay? Okay, let's leave it at that. Finish.